Officer at the Naval Undersea Warfare Center Division Keyport. We're one of 16 labs within the Navy. Now I'll talk a little bit about what we do. I'll open up talking a little bit about me and my background and how I came here as just kind of a example of a career within the DoD and at Keyport here. I'll talk a little bit about the mission and the value of the mission working within Department of Navy. I'll touch lightly on cybersecurity. I will say I have cybersecurity adjacent expertise, but I am not deep in cybersecurity. And then I'll talk a little bit about Keyport. But at any time, if you have questions, feel free to interject. This is more fun as a conversation, and I'll leave a little bit of time at the end. And on that note, just as a time check, I wrap up at 11:45. Is that correct?
Yes, sir. Yep.
All right. Okay. So again, my name is Aaron Darton. I've been at Keyport for about 17 years now. I graduated with my bachelor's in mechanical engineering from Montana State University. Do we have any Montana State folks in the room there? All right, excellent. Go Bobcats. All right, came straight from here, or straight from school to Keyport after I finished my bachelor's. I worked in a number of different parts of the organization. So one of the things that we do is we help purchase and maintain a lot of the systems that go on submarines. So I guess Hunt for Red October is a pretty old reference now. Hunter Killer, maybe a little more contemporary. You think of all the computers and the screens that everybody are sitting at in the submarine. Worked on those types of things, trying to help maintain and sustain those for the sailors. I spent some time out in Washington, D.C. with one of the program offices, effectively doing the same thing, more on the purchasing than the maintaining side. So working with the big defense contractors that we're purchasing them from, defining the requirements, receiving them, validating what we needed. I spent some time as an engineer on the hull mechanical and electrical repair line. So submarines, as you might imagine, have really big pumps and valves and things associated with them. Spent about a year as an engineer supporting the technicians that were doing that type of work. And then following that, pretty well pivoted more towards a research background. So I found that the jobs I'd previously done were interesting, but maybe not my cup of tea to make a career out of. So I pivoted more towards research, doing a lot of acoustics, structural acoustics, ocean acoustics, that sort of thing. I did that for several years before moving into this role, and I've been here for about 5 years now. So what I'm hoping to highlight there is one of the really nice things about large organizations. It doesn't have to just be the government. This is true in industry as well. I didn't know what I wanted to be when I graduated. I thought I wanted to design things. Early on, I had an opportunity to do that. Turned out I wasn't very good at it. I didn't like it. So I moved on and did other things instead. So as you're thinking about what you want to do and where you want to go in your careers, it's certainly okay to not know. I'm still wondering what the next thing is going to be. But that's one of the benefits of larger organizations, is having the ability to do a lot of different things. One of the other nice things about federal service or service within the DoD in particular is we're pretty committed to helping folks continue their education. So as I said, I graduated with my bachelor's from Montana State. I decided I wanted to go back and do some more school. So Keyport paid for me to go nights and weekends to Purdue University and pursue my master's. Through that process, I decided nights and weekends was a lot of work and cut into the fun time. So I continued on to my doctorate. Keyport sent me out to Atlanta to Georgia Tech, and I spent 3 years in Atlanta doing my PhD there. So that's one of the other things to think about. I graduated college 3 times, and every time I did, I said, that's it. I'm never going back after my last final. But somehow end up going back to school again. I really enjoyed it. Got a lot out of it. And it's also nice when somebody else pays for it. So another thing to consider as you're thinking about if you want to go on for school or not. You certainly don't have to decide right away. There's certainly some pros and cons of getting some career experience under your belt before continuing. There's also some pros and cons to going straight through. So all things to consider and think about. And here at Keyport, we have folks that have taken every different path. There's homes for all those folks, and they're able to leverage the things that they gain through those experiences across the command there. So one of the other things I think it's important to talk about when talking about jobs in the federal service and in DoD is sense of purpose and mission. Several different times in my career, I explored what other opportunities might be out there. But one of the things I've found has been a big draw is supporting our men and women in the military and our national security apparatus. It's a really fulfilling place to work. I won't kid you, the federal government is the world's largest bureaucracy, and it feels like it some days. But there's a lot of upside to it as well. So again, as you're out there thinking about what your next steps are, I think those are important things to consider and keep in mind as you evaluate your options. And actually, I'm going to pivot a little bit on my agenda in here. I'm going to walk through just a couple of these slides. There are a whole bunch of slides, and I think I sent them ahead. Feel free to distribute those and go through some of the ones that I skip over, and happy to take any follow-up questions or whatever. Feel free to reach out via email or say by phone. I'm not great at answering my phone emails. Probably higher probability communication there, but happy to talk more if we don't have time today to cover things that you have particular interest in. And then as we kind of go through this, I'll hit some of the cybersecurity pieces. I think that might flow a little bit better. So let's see here. There we go. So I won't spend a ton of time here. Important takeaways from this slide. So Keyport is, 110 years old this year. Most of our background is in torpedo production. So we were stood up in 1914 to produce torpedoes for the Pacific Fleet. And that's been a large part of what we've done. Ever since then, we grew to the point where we were running, 3 shifts a day in our torpedo production facility at the end of the Cold War. But following that, kind of reevaluated what we did and what our contributions were to the military as the Soviet Union fell and kind of the world order changed. And we're, again, if you're watching the news, seeing what's going on in Europe and in Asia, causing us to reevaluate, where we contribute, but it all has a common thread of undersea warfare. And so what is undersea warfare? We, I'll say, take a pretty forward-leaning approach there, and it's, any sort of military capability or support function that comes from, goes within, or into the undersea. So think about things like submarines, torpedoes, undersea drones, undersea sensors, missiles that come off of our submarines, those sorts of things. Those all fall within the scope of what we do. We're spread pretty well across the country and across the globe. I've got a number of sites here on the Pacific coast. The sites outlined there in light blue or a subordinate command has a lot to do with logistics and sustainment. And then you can see across the Pacific, we've got folks in Pearl Harbor and Guam and Japan. And we've got a person or two in Europe as well supporting commands there. So one of the nice things, not just about us, but all our other warfare centers you can see here, these are 10 of our, 9 of our sister labs, and there are a few others in different parts of the Navy. We pretty well support the fleet anywhere they are. So there are opportunities to spend time all across the globe supporting the fleet. In fact, a good friend of mine spent a few years out in Spain at one of the repair facilities out there. So pretty good duty. So I'll spend some time here and spend a little bit more time talking about what we do and try and tie in some of the cybersecurity things. As I'm sure you're all well aware, pretty much everything that we do now has compute, storage, processing, network, and all those things require good cybersecurity design and implementation on the front end, good hygiene throughout the life cycle to make sure that we're keeping our fleet with an advantage and not exposing them to vulnerabilities through those things, right? Those connected systems are a huge enabler, but they have risk as well. So a lot of what we do, and you can see kind of in the bottom middle, cybersecurity systems engineering, one of the things we spend a lot of time on is there's certainly a compliance element. How do you go through and check all the boxes to say we did the things, we did the STIGs, the OS is up to date, all that kind of stuff. But we try and think a lot more holistically about what are vulnerabilities, how do you manage those, what are the risks associated with those vulnerabilities, and really kind of take a cyber physical approach to it, right? We don't spend as much time on the software, although we do have some folks that look at that. A lot of what we do is more kind of the hardware and firmware level, some network things as well. But when we think about our torpedoes, for example, so I talked about that a little bit. We have a pretty big part of our organization that works on, I think I may have said producing, and at some point in our past we did. Really now it's about integrating and maintaining those torpedoes. So the hardware that, torpedoes are different from missiles in that we practice using them all the time and they don't explode. We get them back and we're able to use them again, right? So that's a lot of the functions that we support here, and we support through the point there being those weapons are out there, they're out in the big wide ocean. We got to make sure we find them and bring them home, and if for some reason something were to happen to them, right, we want to make sure that those systems are secure and protect the information that's in them. As just an example, right, the same is true. You see there, the next tile over is on our local undersea ranges. So, above, for you walking around trying to track something, find yourself in Google Maps or Apple Maps, whatever the thing is, we use GPS, right? It's great. Provides us location, time, all sorts of things. It really, again, you guys probably well versed in this, supports a lot of the time synchronization we do across networks and things like that. Undersea, we don't have that, right? We have to find another mechanism to provide location and provide timing to our systems. And we do that through kind of a reverse of GPS. We have a constellation of receivers that correlates signals from the items we're tracking. And we have both fixed ranges around here, but we also have portable ranges. So we can go out anywhere in the world and provide time and position for testing and development, as well as fleet, training and exercising needs as well. Again, there's a large cybersecurity element to that. Anytime we take things out into the big wide world, we let them loose in the ocean. There's always a risk they don't come back, and so we need to make sure that if those things wash up on a beach somewhere, that the information and the software and that sort of thing within them is protected. And the next tile over, again, a lot of the same cybersecurity elements there, so I won't repeat them all. If you watch the news about the war in Ukraine and Russia, you're seeing a lot on aerial drones. They've really changed the way we think about warfare. There's an undersea analog to all that as well. There's probably been to a far lesser extent. You see some of that in the news as well. But that causes us to think, the U.S. Navy, to think about what are we doing? How are we using these systems? How can they provide us advantage? How can we help provide our fleet an advantage using these unmanned undersea vehicles? So for a long time, we've been working on what we'll refer to as the truck. So the actual piece of hardware, the fins, the propellers, the control system, navigation, all those kinds of things. We're making pretty good progress there, but what do we want them to do, and how do we want them to influence the operations of our Navy and those of competitors or adversaries? Again, there's a lot of really important elements when you're sending these items. They're unmanned, so there's nobody there to babysit them or protect them. How do you maintain that security of the system as it goes out in those forward locations, and make sure that when you do provide that security, you're not impeding its operational requirements either, which turns out to be a fairly challenging thing to do. So the next tile over, quite a bit of what we do is how do you command and control all these undersea systems across a theater? So theater, if you're not familiar with that term, think of you're the commander in charge of the whole Pacific Ocean, and you've got groups of aircraft carriers. You've got, with all the ships that go with the aircraft carrier, you've got submarines, you've got unmanned systems, you've got partner nations, you've got, like, again, using the Pacific as an example. If you've heard or seen the term AUKUS in the news, AUKUS stands for Australia, UK, US. So it's an agreement between those three countries to cooperate on national security matters. And the undersea is a big component of it. You'll see them talk about submarines a lot. So now, not only as a commander do you have your own forces to worry about, you have those of your partners as well. So how do you bring all that information together and distill it down into a picture that commander can make decisions from, right? So there's a lot of elements of networking. We don't spend as much time on the pipes of the network, the individual links, but how do we tie into all those things, bring all the information together in one place, I should say, bring all the data together in one place, distill that into information that somebody can make command decisions on. It's a pretty challenging thing to do, but a lot of fun to work on. So kind of spread through these. You hear me talk a lot about what we're trying to provide to the fleet. So you can think of it like a spectrum. As a lab, we've got things going on and kind of that early research phase all the way through figuring out what those applications of those technologies and that research are. through deploying the systems, maintaining the systems, and then ultimately retiring the system. So in that case, we just talked about, we got some neat research going on, thinking about, cognitive workload, how do you use computers, AI, those sorts of things to support the human and take some of that cognitive workload off so they can focus on the things that require experience and judgment, ethics, things that the computers aren't going to do, right? We spend a lot of time thinking about that. And again, as I'm sure you guys have talked about or will talk about, there's some security implications there, right? How do you maintain security through your AI tools, right? If it's something like a large language model, what's the data that that large language model was built on? How do you describe and maintain and manage its pedigree? How do you follow that through the life cycle of that LLM, right? So you deploy it on a system, but then it's going to change as people interact with it if it's a learning LLM. How do you ensure that it's not tainted or poisoned, whether intentionally or unintentionally, all those sorts of questions. There's some really good security questions in there when we start talking about AI and machine learning and those sorts of things. So spend a lot of time thinking about that. On the undersea defensive warfare systems tile, the last one on the top right there, I mean, it kind of is what it says it is. How do we help our ships and submarines defend themselves from undersea threats? Some really interesting work there. Prototyping and custom engineered solutions. There's kind of two things there. Prototyping, we're a lab, right? We have experiments. We have, both laboratories like you traditionally think, folks in white lab coats doing stuff, they need things. We're out going in water, taking prototypes out. We need to build those. And then just support for our own systems, right? So we have a lot of really capable engineers, computer scientists, a lot of, and now growing to be a lot more mathematicians, data scientists, things like that, helping us develop things. And then on the custom engineered solutions side, that refers a lot to helping to maintain older systems, right? So it's kind of a dated example now, but we used to have within many of our platforms mechanical gyroscopes, right? So you think of something that has a spinning mass, and you look at perturbations of that spinning mass to tell you if you're gone left, gone right, gone up, gone down. It's a pretty high failure system when you've got moving mechanical components. So someone asked, hey, can you take a look at this and come up with something that doesn't fail as often? And so we developed a solid state system. So that's the kind of things that group is doing. They're trying to find ways to resolve challenges for the fleet. Data science and analytics, very broad. It covers everything from our business systems to our maintenance systems to how are we developing new systems. And a lot of those same challenges we talked about with AI and machine learning apply here, even if we're not using non-deterministic methods like that. How do you have pedigree of your data so that you can trust the answer that comes out of it? Cybersecurity or cyber system security engineering, it kind of hit on through all those things, but we do have a dedicated group that does just that. They look at both, like I was saying, kind of the compliance side. How do we make sure that our system, we have good system hygiene? We're doing the updates, we're doing the patches. Those, we've got the right, security mechanisms in place, authentication, all those kinds of things. And then a little bit more of the free form, open thinking, how do we identify vulnerabilities? How do we think about those? How do we turn those into risks or evaluate those in the context of the risk a risk having both a consequence, like how bad is it going to be if it happens, and then likelihood, how likely is that to happen? So we try and use all those things to help us understand what are the things we should be doing to protect our systems. Then the last tile down there, or sorry, second to last tile on the bottom and to the right, sustainment and maintenance innovation. So we do a lot of things with automating maintenance and sustainment technology. So think of, what we've got depicted there as a hull crawler that goes on a submarine, and it's got, different inspection sensors on it. And so it can crawl around and try and find problems without a person having to go literally crawl over the hull and check the whole thing or parts of it and try and make sure it's in good material condition. And the last thing over there, one of the things that's pretty unique about Keyport is we do have the fleet's unmanned undersea vehicle, undersea drone component here, or some components of them. So we have the Major Command that has, under that has 3 squadrons that go out and operate UUVs for the fleet. That Major Command and one of those squadrons are located here. So it's really nice that we're able to sit side by side with the fleet, understand how things are working, understand what things aren't working, and help address that for them. And that's pretty unique to Keyport. Most labs don't have that. So we try to not only help ourselves, but help our sister labs with that as well. And scenario, we're also able to bring in industry as well. So as folks are designing the next UVs or payloads for them, those sorts of things, we can bring them in and have them work directly with those operators. So I've talked for a while. I got a few more slides here, but I'll pause for a moment. That's kind of the what do we do part, and tried to highlight some of the cybersecurity pieces that fit into each of these tiles, because it really does cut across all that we do. So any questions there before I move on?
I don't see any comments. Yeah, Aaron, Bernie Van Wee here. Thanks again for joining us. We so much appreciate it. The field trip you gave us a couple of years ago, we'd love to come back, and this program continues. Can you give the students a kind of a perspective on how many military people you employ at the Naval Undersea Warfare Center, and how many civilians? I got the impression it was mostly civilians.
Yep.
But, and I think it would be helpful for these students to know, and also to know something about internships and so forth, if you're not going to already be talking about that.
Yeah, no, great point. And I typically cover this at the front, and I'm realizing I did now. One of the things I didn't know when I graduated and started working here is that you have non-military personnel that work for the Navy. So and pretty much, I'll say everybody with a handful of exceptions at Keyport is a civilian, right? So, I don't wear a uniform. We don't carry guns. We don't get deployed. We are civilians, but we are employed by the Navy. So we are federal employees. We are civil servants, as is distinct from active duty in the military. So this is a great segue. So we're about 2,700 civilians. There are 31 military personnel here. They're mostly comprised. We have a head of our organization, our commanding officer. There's a civilian and a military head. So the military head and his staff, and then we have a group of divers, refer to them as the dive locker, that support a lot of our operations, make up those 31 personnel. So the commanding officer, his staff, and then that dive locker are about the only personnel that are part of Naval Undersea Warfare Center Division Keyport. However, we're co-located with about, I think there are around 200 now active duty that are associated with the UUV group and the UUV squadron, which are two organizations, one subordinate to the other, that are here at Keyport, but they're not part of here on our location, but they're not part of our lab. We're about a quarter scientists and engineers. We have a fair number of administrative folks, both supporting us directly, but also supporting the programs that we work on. We have a fair number of technicians, so think machinists, folks who build the electronics, folks who work on the torpedoes, work on the ships and submarines that we use. Submarines, we don't own any submarines. The ships that we use, excuse me, on range and those sorts of things. So that's kind of our makeup. And then you can see on the right, a large number have bachelors, and of that, almost half, not quite, have masters. And we're really growing that PhD number. It was about, I want to say 6 or 8 when I came into this role 5 years ago, and we've been pushing pretty hard to grow that PhD component to better reflect and support the more research end of what we do. And Bernie, I'll come back to the internships. I'm not sure that slide is in here, but I was going to talk to it anyways, and I can send out some information afterwards on that. So that's the makeup of kind of who we are at Keyport. I'm going to hop through these slides that kind of go into more detail on some of these specific areas, since nobody had any questions, but I can come back to them. This is the other part, and this is where I'll talk about the internships a little bit and hiring opportunities. But one of the things that's unique to us as a lab is we have specific authorities that allow us to engage with universities, with and industry. Really, we do with large companies as well, but really thinking about startups and entrepreneurs and those sorts of things. And so this, it's a little bit of wall of words. I apologize for that, but trying to capture the breadth of things that we do. So we do a lot of outreach, kind of at the undergraduate level through senior design projects. We do a lot at the graduate level with different research programs. So we have the Naval Engineering Education Consortium, the Naval Undersea Research Projects. We do our own grants, and then we'll collaborate on proposals and on projects with universities, right? So we're not the ones necessarily awarding the dollars. It might be something like the Office of Naval Research. Well, we'll go and work with them. And we have some special authorities so we can enter cooperative research and development agreements, which basically means each of the two parties brings their own money and works together on a topic. And that other party could be a company, a startup, an entrepreneur, a university. We have educational partnership agreements, which we have one with, I think, several of the universities represented here. We have what's called partnership intermediary agreements, which a lot of legalese there, but again, they're meant to help us engage and pull technology out of those places and into our programs, but also take technology we've developed and put it back out into the commercial space. So that's one of our mandates as a federal lab is that the things that we work on, insofar as they're not classified or otherwise protected, they're supposed to go back out for the public good. So you take all those things together and we pair them up against our internship opportunities, so things like the Naval Research and Engineering Internship Program, NREAP is how we refer to it. The SMART program, which the SMART is an acronym there too, because we do love our acronyms. I don't remember what it stands for, but that's so NREAP is an internship. SMART is a scholarship. So we'll pay for your school, we'll give you a stipend, and we'll give you an internship, and we give you a job when you're done. So that's a pretty good one. And then through engagements like this, right? So I don't know if you've talked much about Viceroy and those things yet, Bernie, but we work very closely with AFRL and Viceroy and those internships as well. And there are a few other cybersecurity specific ones I can send you more information on there. But there are a lot of different opportunities to either come here and work in the summer and try it out. I think it's really good for us to both parties to spend some time with one another before we decide if we want a longer term hiring relationship. We have opportunities with SMART as well, both to pay for your school and then have you come work here, so you never have to go to a career fair and do the awkward career fair thing. And then we try and engage through these different research opportunities. And I apologize for not having it offhand, but I believe we have some ongoing research with Washington State University, Montana State University. I'm not sure if we have anything with University of Idaho or not at the moment, but we have in the past, and I know there's some things we're contemplating. And through those engagements, sometimes we'll even just bring students on, particularly more for our local schools, but we've done it other places too, where we bring in students as temporary hires while they're in school, and they're able to get credit for that work as well. So we have a lot of different mechanisms. I'll send some information over to you, Bernie, kind of a one-sheeter that has a bunch of that stuff. But I'd really encourage, if that's something you're interested in, reach out to myself, and I'll just be upfront and honest. I will probably get you then in touch with Ty Tran in my office here, who can help you think through what are the right options, because there are a lot of them, which is great, but it does make it it can make it a little confusing on your end. So happy to work with you through those and find the things that make sense. The thing that is fairly consistent for all of them is those application periods are in the fall. So about the time, if you're on a semester system, about the time you're coming back to school and running up through either the end of September or end of October, or the end of the semester, kind of December timeframe, depending on which program you're talking about. Those are some of the deadlines. So we can get some of that information out to you now. It's a great time to start asking questions, and we can get you in touch with different folks here across the organization, the different work groups that you might work with and might fit against your interests and skills, so you can start having some of those conversations so that you're ready at the beginning of the fall semester to start applying. I don't know that any of the applications are that onerous, but they do require letters of recommendation, which can take a little follow through on your part to make sure your recommenders get their letters in for you. So highly encourage working on it well before the due date, because they're automated systems that when they're closed, they're closed. We don't really have good opportunities to go back and get a late submit or anything like that. So the big ones are going to be NREAP, for you guys, Viceroy for sure, and SMART. And then there are a couple of cybersecurity ones too that I'll include, but those are the ones I'd focus on.
Thank you.
Great. So with that, I'm just kind of in the interest of time. I won't. These slides are available for anybody who wants them. If you have follow-on questions, feel free to get in touch with me. But I'll pause there for any other questions.
Yeah, if you'd like a few extra minutes, Dr. Carr, that's fine. You can use it.
Okay. Well, unfortunately, I've got a meeting here. I got to run over to another building for at the top of the hour, so I will probably have to wrap up on time. But again, happy to have follow-on conversations with anyone that's interested.
Thank you so much. We really appreciate the time.
All right. Well, thank you. I'll send over some additional information on the scholarships and the internships, and feel free to reach back out with any additional questions.
Great, thank you.
All right. Thanks. Enjoy the rest of your day and rest of your week.
So if some of you want to stay in